In the module today, we're going to talk a little bit about boundary value testing, a very simple idea and concept that most of you are already familiar with, but I'm going to expand it a little bit and certainly be defining it in a way that perhaps you've never heard it before. So we've just got one objective. We're going to talk about how we apply the boundary value testing technique as one of the many other techniques that we're using as a part of our overall black box functional testing strategy. So our definition is going to be very simple. What is boundary value testing? It's going to involve selecting test cases to test boundary conditions. Most of you are probably familiar with that, right? Obvious. But now look at the definition. Corresponding to situations directly on, above, and below the edges of both input and output equivalence partitions. So basically we're defining boundary values in terms of equivalence partitions. So let's go back to one of the problems that we were doing in class. We were looking at trying to go in and validate a password, and we were looking at the length. One of the attributes of a password was the length. And if I recall, we talked about the length being between 6 and 10. So when we were doing equivalence partitions, we were basically saying we could consider length as being an attribute. We're not going to try every possible length. Typical partitions for the length would have been 6 to 10, which we would have viewed as being a valid partition. Try something less than 6, try something greater than 10. And we were doing equivalence partitions, we were done. Now we're going to worry about boundary values. So back to our definition. Selecting values directly on, above, and below the edges, in this case, of input equivalence partitions. So when we're looking at the edges here, we've got an edge right here, and we really have on, above, and below. We've got 6, we've got 5, we've got 7. And in a similar way, we've got another boundary here, and looking at on, above, and below is basically going to give us 9, 10, and 11. So theoretically, and based on this definition, there are actually 6 boundary values. Now in practice, when we're actually starting to do things, we don't normally worry about the values that are part of the inclusive boundary. So a more realistic, more practical view of the boundary values here would be to try a password of length 5, try password of length 6, try password of 10, and try one of 11. All right? And that's as simple as it is. That's boundary value testing. Now, connecting the two, equivalence partition and boundary values, on a problem, if we know we're going to be doing equivalence partitioning, and if we know we're going to be doing boundary value testing, can be smart enough in selecting test cases to try to select values that satisfy both at once? Well, the answer is of course. So if I were going to be, again, attempting to test password, the attribute of length 6 to 10, using the combination of equivalence partition and boundary value testing, what would I pick? Well, I know with equivalence partitioning, I need to try a value less than 6. Any value would work. 3, 2, 5, it doesn't matter. But if we're doing both of them together, boundary value says, hey, it matters to me. And so the value that one would select to satisfy both boundary value testing and equivalence partitioning for less than 6 would be the value of 5. 6 to 10, any valid value in that range will satisfy equivalence partition. Try 8, try 7, doesn't matter. If you're trying to satisfy both, well, if any values will satisfy equivalence partition in the 6 to 10 range, boundary values is a little bit more particular. It's going to want us to try 6, and it's going to want us to try 10. And finally, any value greater than 10 will satisfy the equivalence partition. Boundary value says, I care about 11. So combining equivalence partitioning and boundary value testing for this problem would generate the 4 tests that I've just represented. Now, back to our definition. We talked about testing input, but we also need to, when we're reading over our problems and understanding our testing, thinking about output boundary values. Output boundary values. And what are those? Well, again, it depends on the context of the problem. But let's go into, for example, a payroll program. And one might identify maybe an output boundary indicating that no paycheck shall be generated equal to or greater than $10,000. Okay? You just will not do that. Maybe without lots and lots of additional permissions. So how would you go about testing that? Well, a typical payroll program is going to have a lot of inputs. It's going to have hours and pay rates. And if I was referring to this as being a net pay, well, then we're going to have to worry a lot about deductions and taxes and everything like that. So imagine for a moment, thinking about these as being our inputs, generating some inputs, coming up with some values for these, shooting them into the system, and getting back a result of 999.97. And the system prints that, indicates that's a valid check. We tweak things a little bit more, and we generate a result, 10,005, and it rejects it. Can we regard this as being boundary value testing? Well, no. Because boundary value testing actually requires us to test the boundary conditions. So we would have to literally tweak our data input to get to that 999.99, show that it generates it as being okay, and then tweak it a little bit more to create the 10,000 that I indicated should be rejected. Can we do that? Yes, we can, but it's hard. How hard would it be in a program like this to tweak the inputs to land exactly on those boundaries? Probably about as hard as attempting to fill your gas in your car, with an exactly $10 amount, right? I mean, it's so hard, okay, to be able to land right on that exact amount. In practice, though, how complex is the software that's implementing this output boundary condition? Well, I'm sure you'd recognize not very, right? Probably it's a single if statement that's looking at, the net pay, comparing it to the 10,000, and if it's greater than or equal to, rejecting it. So we can continue to test, trying to land on those boundaries. But remember, testing is just one strategy. And in reality, probably the best way for being able to determine that boundary value is indeed correct and being met might be by going in and doing a code inspection, at which point we can run some tests, but ultimately we might want to verify this requirement is being met by ultimately looking at the code, and that would be an inspection. So kind of in summary, what we've done is we define boundary values, and we define boundary values in terms of the edges of equivalence partitioning. But most importantly, as we start to combine testing techniques, we talked about how one would combine equivalence partitions with boundary values, and not forgetting that we're putting the emphasis on both inputs and outputs. Thank you.